Workplaces that manufacture engineered wood products or wood pellets may be at risk of fire, deflagration, or explosion due to the buildup of combustible off-gases within enclosed areas, such as buildings and process equipment like dryers. We've had a number of combustible gas explosions in BC and Alberta. The incidence of these types of explosions can be mitigated if we understand the cause better. So, recognizing the areas and processes that might be susceptible to a buildup of combustible gas allows us to find ways to prevent potential explosions from occurring. What is combustible gas and how is it formed? Combustible gas consists of mainly carbon monoxide, hydrogen and methane, or natural gas. These gases are produced from incomplete combustion in process equipment. Stored wood pellets may also emit combustible gases, especially during self-heating. Oxygen must always be present in the air to initiate combustion and explosion. The decomposition process, known as pyrolysis, produces gases such as carbon monoxide, hydrogen, and methane, as well as volatile organic compounds, or VOCs. The resulting gas mixture, called syngas, is flammable and when in high concentration can be explosive. Syngas is usually discharged to the atmosphere without significant hazard. However, it can accumulate within combustion or drying systems, including ducts and cyclones, if the process ventilation system does not extract the syngas effectively. For example, during a power failure or outage, the combustion or drying system can continue to create syngas with a restriction or complete loss of ventilation within the system. Without electrical power to operate extraction fans, syngas can quickly accumulate within the system. Also, a faulty, dirty, or clogged ventilation system may prevent syngas from discharging. Accumulation of sufficient amounts of syngas poses a risk of fire or explosion in the presence of an ignition source and sufficient oxygen. This may occur in enclosed spaces such as dryers, dryer cyclones, combustion chambers, ducts, or pipes. Another source of fire in the dryers could be wood fiber itself. If the fiber is dried to the point where there's little remaining moisture and the wood fiber is still exposed to the high-temperature environment, the chemicals within the wood fiber can decompose, forming combustible gas. There is a growing demand for pellets made from other forms of solid biomass, especially from agricultural residues. The same combustible gas risks and safety considerations apply to agricultural residues as for wood. When is a fire or explosion most likely to occur? Syngas is usually created during heating or cool-off periods in burners, dryers, ducting, and other equipment. The highest risk times during regular operations are during startup, when systems are heating, and shut down during cooling-off periods. Processes that burn wood at high temperatures or that gasify and burn wood will usually burn off syngas. However, mid to low combustion temperatures between 140 and 180 degrees Celsius, depending on the wood species, can cause incomplete combustion, which may lead to syngas generation within the drying system. Blending various species in feedstock increases the probability of partial combustion in drying units. The greatest risk is when there are sudden, unexpected power outages or power bumps. Dryer component failures such as plug cyclone, in-feed airlock jam, or faulty control dampers. Faulty fire protection equipment such as plugged or missing deluge nozzles, or faulty solenoid valves on extinguishing valves. Or distracted operations where another part of the plant is having issues, causing the drying equipment to be shut down too fast. So how can we reduce the risk of fire or explosion? The production of syngas can be highly complex, and syngas can accumulate in multiple places within the system. The accumulation of soot in the ducts may also be a source of fire. Operator vigilance and an intelligently designed alarm and control system are crucial in reducing the risk of syngas fires and explosions. Conduct a risk assessment to determine when and where syngas may accumulate and which control options will be most effective at managing the risk. Here are some common controls that can mitigate the risk. Have backup power generation available. This is the first step in reducing the risk of a syngas fire or explosion. Syngas is likely to accumulate when induced draft extractor fans fail to operate, such as during a power outage. If power is continuous, the fans will continue to operate and syngas can be vented to the atmosphere safely. A properly designed ventilation opening should exist wherever combustible gas accumulation is possible. For example, in a dryer to take out the potential deflagration gases generated in the event that fans stop working and no gas movement exists during a power outage or failure. Install monitoring systems, such as oxygen sensors within your drying or combustion systems. These systems will help your operator know when syngas levels increase so they can take action to avoid a fire or explosion. Keep your ducting and dampers clean and make sure your venting is effective. Carry out periodic inspections. Keep up with ongoing maintenance, including cleaning to prevent unwanted debris buildup where syngas can be produced and accumulate. Design your alarm system and procedures to ensure control room operators can respond effectively. Make sure alarms are easy for operators to understand. Periodically review your systems and procedures to ensure they are effective. Be vigilant about ensuring your staff contractors, engineers, and installers follow prescribed procedures. In a complex system, keeping to a detailed, up-to-date checklist and recognized standards can help ensure nothing is missed. This is important during installations and maintenance, as well as during normal operations. Make sure that all staff are trained in the use of these procedures. Design your operation units and control systems for your specific feedstock. Be vigilant about blending various species. Being vigilant about mitigating the risks associated with combustible gas will help us prevent injury and damage to equipment. A reminder, although this video has concentrated on combustible gas risks and safety considerations for woody biomass, the subject matter in this video applies equally to the processing of agricultural biomass.